Hello students, a pleasant good evening to everyone, and I am back with another very important topic, that is fuels, lubricants and explosives. వస్తుందా సార్? ఏం ఆన్ కావట్లేదు.
Hello.
ఇది రావట్లేదు కదా సార్? ఓకే. So, a pleasant good evening to everyone and students. I am myself Chandra Prakash, Faculty of Chemistry Ecet, and this is Ask Engineering Academy located at Dilsukhnagar, and this institution is offering various courses, especially for the technical courses such as Ecet, BTech and backlogs, as well as NEET and MCET also. And basically I am from Osmania University and I have completed my masters there, and I have rich experience in teaching these kind of courses. And now in the last class we have discussed some of the very important concepts of chemistry. Today we are moving on to one more important thing and one more important concept in chemistry, which is always in close contact with the human being, because today's topic is more relevant to the human life, because we can't imagine the presence or existence of human life. Because of only these things we can make the human life possible on this earth. So the today's topic is fuels, lubricants and explosives. So today's topic is fuels, lubricants and explosives. So in these concepts we must understand what is meant by fuel, what are lubricants, what are explosives. And coming to the fuels, in order to make understand the fuel concept more precisely, we have to know what is fuels and what are the characteristics of fuel and what are the properties of fuels, how the fuels are different types of fuels will be there. So such kind of things will be studied under fuels. Now in the case of lubricants, what are lubricants, what are the functions of lubricants, why the concept of lubricants was included in the Ecet. So that is what we usually studied in this. Next, explosives. What are explosives? How the explosives are classified into various categories. So these kind of information can we get by today's topic. Now first of all we move on to fuels. What are fuels? Now fuels. Under fuels we first study about definition of fuel. Definition of fuel. Second one, classification of fuels. Classification of fuels. Third one, characteristics of good fuel. Characteristics of good fuel. Just a minute, make my phone silent. So characteristics of good fuel. Fourth one, characteristics of good fuel. Concept of calorific value. Calorific value and its units. So first, in the fuel concept itself, these are the main areas we generally focus. The first one is definition of fuel. What is meant by definition? What is meant by fuel? How the fuels can be produced? And classification of fuels. There are many fuels, how they are classified. And third one, characteristics of good fuel. How can we say this kind of fuel is good and that kind of fuel is bad, and based on what parameters we can differentiate the bad fuel from good fuel and good fuel from bad fuel, we will study in this. And characteristic of good fuel completed. Concept of calorific value. What is meant by calorific value? What are its unit? How the calorific value concept is interrelated with fuels. So these kind of information we will study in today's topic. First we are moving on to definition of fuel. So fuel definition, fuel definition. What is meant by fuel? So fuels are nothing but the fuels are the substances that can able to combust. The fuels are the substances that can able to combust, or the substances which are combustible in nature. Combustible in nature. Fuels are nothing but substances which are combustible. What is mean by combustible? I will make you understand this. Combustible. Substances which are combustible in nature. Combustible in nature. And the main constituent of fuels is carbon. And main constituent of fuel is carbon, is the main constituent of fuel, and hydrogen. So they are commonly called as hydrocarbons. So now based on the definition we can define that fuels are the substances which are combustible in nature, and the major portion of or major composition of fuels are made up of both carbon and hydrogen. Because of that reason fuels are also called as hydrocarbonation nature. So combustible in the sense what? I highlighted intentionally combustible. Ante entante combustible in the sense anything that can able to combust, means anything that can have ability to burn ability undadam annamata. For example, this pen, it is not combustible in nature. Moreover, whenever we apply some temperatures or some heat to it, it will combust. So the pen is combustible in nature. Combustible means the ability or the nature of substances to undergo combustion, so burning. So that property of material is called as combustion. So the combustible substances in which the carbon, hydrogen are main constituents. So such kind of things are called as fuels. For example, what is meant by combustion? Burning. Simply combustion is nothing but burning or combustion. Generally combustion done in the presence of oxygen. Oxygen, our universe and our nature consists of oxygen. The oxygen is one of the material which enables the substance to undergo combustion. Similar kind of combustion process will also happens within our human body cells, because in our body we are producing energy. How energy is producing? Because we are taking oxygen. This oxygen is entering onto our cells. At the cells will be in the presence of oxygen. The glucose in the cells which is already present undergoes combustion. As a result of combustion between glucose and oxygen, energy will be generated. So same manner, fuel in the presence of oxygen. Fuel in the presence of oxygen. Fuel contains carbon and hydrogen. So hydrocarbons in the presence of oxygen undergoes combustion to produce energy. So now you understand what are fuels. Fuels are the substances that contain carbon and hydrogen which are combustible in nature in the presence of oxygen to produce energy. Now fuels are the substances that combust to produce massive amount of energy. That energy is utilized for various purposes, both domestically and industrially. So this energy can be utilized for both industrial purposes and domestic purposes. Both industrial purposes means this energy is required for the production of industrial products. So industries are there there are a lot of products are generating day by day from industries. So in order to generate one product, we need some amount of energy. That amount of energy can be get by these combustion of fuels, and it's also used for domestic purposes. For example, kerosene, diesel, petrol, all those are fuels, because automobile sector is completely based on fuels. And domestic in the sense, gobar gas, biogas, methane, and kerosene. We use kerosene in the ancient days, now stoves. In the ancient days, we used to apply kerosene so that whenever we matchstick, in the presence of oxygen, the kerosene will burn, so that energy will be produced. That is, energy is called as heat energy. In the presence of heat energy, we can able to cook food. So this is what the energy is generated from the fuel. Now coming to definition is completed. Now classification of fuels is also very important. First, classification of fuels. Classification of fuels. Classification of fuels. Generally, how, before classifying the fuels, first of all we need to understand how the fuels are formed, from what source we are getting fuels. The first and primary source of fuels is earth crust. So the primary source or important source, primary source of fuels is earth crust. Earth crust. This is very important. The primary source of fuels is earth crust. Earth crust ante enti mana bhoomi undi chudandi, earth surface of the earth is called as earth crust, because it is the first and most important layer of earth. Earth crust is the source of fuels. How the earth crust is the source of fuel? For example, there is a plant, there is a tree. We know that after few days of time, after some years, all the leaves that are present on the branches of trees will be fell off. These leaves and everything will be gathered on the surface of earth like this. These are the leaves, and this contain also, it contains dust particles. So the dust particles and leaves and everything, whatever present in the atmosphere, on some fine day, everything will be fell on the surface of the earth. If these substances, due to the accumulation of these substances on the surface of earth for millions of years, if this process happens for millions of years, meanwhile, due to the decomposition of all those organic matter present on the earth surface, so they will converted into this organic matter, the leaves or dust particles, whatever the substances which are fell on the surface of earth, on one fine day, over a million years of time, they undergo repeated chemical reactions. As a result of those chemical reactions, they convert into fuels. This is how fuels are produced. Now we are coming on to classification of fuels. Generally, the fuels are basically classified into two types, based on the basis of two. These are the two criteria. This is a criteria 1, this is a criteria 2. Based on these two criteria, the classification of fuels were formed. First criteria is based on source. Based on the source, the fuels are classified. And second criteria is state of aggregation. State of aggregation. Based on these two criteria, one is source, another one is state of aggregation. Based on these two important parameters, the fuel classification was well established. So based on source, first there are two types of classifications. So one is source, one is based on the source. First one is again classified into two types. The first one is natural, based on source. One is natural fuels, one is artificial fuels. One is natural fuels and artificial. Natural fuels are also called as primary fuels. Primary. Artificial fuels are also called as secondary fuels. So based on the criteria of source, the fuels are classified into two types. One is primary, one is source state of aggregation. Depending upon source, again these are classified into two different types. One is natural fuels or primary fuels. Second one is artificial fuels or secondary fuels. Now we are going to discuss about source, based on the source. Depending upon source, two types. One is natural. Second one is artificial. So natural, based on what are natural fuels now? Natural fuels is nothing but the fuels which are directly isolated or directly taken out or directly extracted from the nature. For example, earth is a part of nature. So if we extract that fuel directly from the earth crust, then those fuels are called as natural fuels. So these are directly get from nature. The best examples for the natural fuels are, first one is, these are the best examples, you have to remember these examples. One is coal, petroleum. Coal, petroleum are the best examples for the natural fuels, because coal, petroleum are directly, we can extract them from earth crust. So these two are very important examples for natural fuels. Now artificial fuels means these are not directly extracted from the earth crust, but these artificial fuels or secondary fuels can be formed from primary fuels. So can be formed from primary fuels. ఈ ప్రైమరీ ఫ్యూల్స్ ఏదైతే న్యాచురల్ ఫ్యూల్స్ ఉన్నాయో దాని నుండి కనుక ఫ్యూల్స్ మనం ఎక్స్ట్రాక్ట్ చేయగలిగితే దోస్ కైండ్ ఆఫ్ ఫ్యూల్స్ ఆర్ కాల్డ్ యాజ్ ఆర్టిఫిషియల్ ఫ్యూల్స్. కెన్ బి ఫార్మ్డ్ ఫ్రమ్ refining of primary fuels. Refining of primary fuels. The best examples for the artificial fuels are, first example is kerosene. I think you are might familiar with this thing. Kerosene, charcoal, coke, diesel. So these are the best examples for the artificial fuels. These are the fuels which are isolated from primary fuels by various refining process, whereas natural fuels are directly extracted from earth crust. For example, coal and petrol. So this is what about one of the classification of fuels based on the source. Now we are moving on to classification based on state of aggregation. Based on state of aggregation. So based on state of aggregation, the fuels are mainly classified into three types: 1, 2 and 3. So first type, second type and third type. First type is liquid fuels, and second one is solid fuels, third one is gaseous fuel. So based on the state of aggregation is nothing but physical state. Based on their physical state, the fuels are classified into again three categories. One is liquid fuels, one is solid fuels, one is gaseous fuels. What are liquid fuels? We know that liquid fuels means these are the fluids, these are the fuels which are in liquid state. The best examples are kerosene, diesel, petrol and some oils also. So these are the best example for liquid fuels. Now solid fuels, best example is coal, coke, charcoal, wood. So these are the best examples for solid fuels because they exist as solids. Now gaseous fuels means LPG. I will explain what is meant by LPG, and CNG, biogas, producer gas, and biogas, producer gas, and water gas, and also methane. So these are all examples for gaseous fuels, these are examples for solid fuels, these are examples for the liquid fuels. So this is one of the classification based on their physical state. Now this is all about classification of fuels. Now we are moving on to characteristics of good fuel. Before that, we must get an idea about what is meant by calorific value. After the completion of calorific value, we will move on to characteristics of fuels. Now we are moving on to calorific value, which is very, very, very important concept. Calorific value. What is meant by calorific value? Calorific value means, I already said, the fuels are the substances that are combustible in nature. So how can you define whether the particular fuel has this much of combustible power? So based on the calorific value, we can say that is calorific value means the total quantity of heat liberated when unit mass or unit volume of fuel is completely burnt. So calorific value is defined as the total quantity of heat liberated, the total quantity of heat liberated when unit volume or unit mass of fuel burned completely. So it is nothing but the total amount of heat liberated when unit mass or unit volume of fuel burned completely. అంటే ఒక యూనిట్ మాస్ ఉన్నటువంటి ఫ్యూయల్ ఏదైతే ఉంటుందో అది కంబషన్ జరిగినప్పుడు ఎంత అమౌంట్ ఆఫ్ హీట్ ఎనర్జీని లిబరేట్ చేస్తుంది, ఆ టోటల్ హీట్ అమౌంట్ ఆఫ్ ఎనర్జీ ఏదైతే ఎనర్జీ ఉంటుందో దాన్ని క్యాలరిఫిక్ వాల్యూ అంటాం. అంటే ద ఫ్యూయల్ దట్ ఎమిట్స్ ఆర్ లిబరేట్స్ మోర్ అమౌంట్ ఆఫ్ ఎనర్జీ ఇన్ ద సెన్స్ it has more calorific value. The one which has more calorific value is considered as good fuel. So calorific value, if CV means calorific value, is directly proportional to good fuel. If the calorific value is more, the fuel function is also more. So this is what fuel. And calorific values also contain some units. So units are very important in the point of chemistry, especially for your Ecet exam point of view. So I think in the previous years also, I think some of the questions are asked in terms of units of calorific values. So units in the sense, generally the calorific value is generally termed in or expressed in kilocalories per gram. This is a one unit. And next calorie per gram, and one more important thing is kilocalorie per meter cube, and fourth unit is BTH. Just a minute. BTH by LB, BTHU by LB. See, these are the units in which the calorific value is generally expressed. First unit is kilocalorie per gram, calorie per gram, kilocalorie per meter cube, BTHU by LB. BTH in the sense, B stands for British, thermal, TH stands for thermal, U stand for unit, by lb of pressure, loops. British thermal units also one of the unit in which the calorific value is generally expressed. This is all about calorific value. Now calorific value means the total amount of heat liberated when one unit mass or one volume mass is completely burnt. So that heat is called as calorific value. If the calorific value of fuel is more, the function of the fuel is also efficient. And these are the units in which calorific value are generally expressed. One is kilocalorie per gram, calorie per gram, kilocalorie per meter cube, BTHU by LB. BTHU means British thermal unit by LB. So these are the general units for calorific value. Next we are moving on to characteristics of good fuel. How can we say a fuel is very good? So those are the characteristics. Characteristics of good fuel. What are the different characteristics of good fuel? First, important thing you must notice this is, first is it must possess high calorific value. First characteristic of good fuel is, if the fuel is very good, then it must possess high calorific value. Next, low ignition temperature. Low ignition temperature. Second, third one, low moisture content. Low moisture content. Next, fourth one, moderate velocity of combustion. Moderate velocity of combustion, and it should not produce, it should not emit, simply it should not emit hazardous substances. Hazardous substances, and it should be of low cost. So in order to say any fuel is very good, so that fuel should satisfy these 5 things or 6 things. One is high calorific value. High calorific value. If the fuel has high calorific value, it produces more amount of energy. If the more amount of energy means the applications are also more. So that's why the fuel with high calorific value is good fuel. Low ignition temperature. Low ignition temperature means, I already said, the fuels are the combustible substances. They can catch fire immediately. So the fuel which is considered as good, it must need very little amount of heat to undergo combustion. అది కంబషన్ అంటే మండాలి అంటే మనం కొంచెం అమౌంట్ ఆఫ్ టెంపరేచర్ని మాత్రమే ప్రొవైడ్ చేసే విధంగా ఉండాలి. అలాంటి ఫ్యూయల్స్ మాత్రమే గుడ్ ఫ్యూయల్స్. సో గుడ్ ఫ్యూయల్స్ ఆర్ నథింగ్ బట్ ద ఫ్యూయల్స్ విచ్ నీడ్ జస్ట్ less amount of temperature, that is called as low ignition temperature. Next, low moisture content. Any fuel is considered as good fuel, it must possess very less amount of moisture. తేమ అంటాం మనం. సరే, అంటే తేమ అంటే ఏంటంటే వాటర్ వేపర్, సింపుల్ హ్యూమిడిటీ. సో ఒక ఫ్యూయల్లో కనుక వాటర్ పర్సెంటేజ్ ఎక్కువ ఉంది అంటే అది మండడానికి ఎక్కువ టైం తీసుకుంటుంది. అంటే ఏంటంటే మనం జస్ట్గా మనం మంట పెట్టినప్పుడు అందులో వాటర్ ఉందనుకోండి, అది అంటుకోవడానికి చాలా టైం పడుతుంది, ఎందుకంటే అక్కడ మాయిశ్చర్ కంటెంట్ ఎక్కువ ఉంది. సో అది గుడ్ ఫ్యూయల్ కాదు. గుడ్ ఫ్యూయల్ అంటే ఏంటంటే ద గుడ్ ఫ్యూయల్ విచ్ ఈస్ కంప్లీట్లీ ఫ్రీ ఆఫ్ మాయిశ్చర్. దట్స్ వై ఎనీ ఫ్యూయల్ దట్ ఈస్ విత్ లెస్ మాయిశ్చర్ కంటెంట్స్ ఈస్ కన్సిడర్డ్ యాజ్ గుడ్ ఫ్యూయల్. సో లో మాయిశ్చర్ కంటెంట్. నౌ మోడరేట్ వెలాసిటీ ఆఫ్ కంబషన్. Moderate velocity of combustion in the sense, velocity of combustion అంటే కంబషన్ జరిగే స్పీడ్, the speed of combustion process. If the speed of combustion process is very less, ఒకవేళ కంబషన్ అనే ప్రాసెస్ చాలా స్లోగా జరిగింది అనుకోండి, వీ హ్యావ్ టు అప్లై మోర్ అమౌంట్ ఆఫ్ టెంపరేచర్. అలా టెంపరేచర్ మనం ఎక్కువ అప్లై చేయాల్సి వస్తుంది. సో ఆ వెలాసిటీ ఆఫ్ కంబషన్ అనేది స్లోగా ఉండకూడదు. ఇట్ షుడ్ బి మెయింటైన్డ్ ఇన్ ఎ మోడరేట్ వే. So this is what one of the characteristics of good fuel. It should not emit hazardous substances. We know that once the fuels are completely burnt, it will produce some kind of byproducts. those byproducts are sometimes harmful to the nature. It also causes pollution. So for a good fuel, it must emit non-hazardous substances but not hazardous substances. అంటే ఒక ఫ్యూయల్ అనేది గుడ్ ఫ్యూయల్ అనుకుంటే అది బర్న్ అయిన తర్వాత యూస్ఫుల్ ఎకో ఫ్రెండ్లీ బై ప్రొడక్ట్స్ మాత్రమే ఎన్వైరన్మెంట్లోకి రిలీజ్ అవ్వాలి. సో దట్ ఈస్ వన్ ఆఫ్ ది క్యారెక్టరిస్టిక్స్ ఆఫ్ గుడ్ ఫ్యూయల్. సో నెక్స్ట్, లో కాస్ట్. ఇఫ్ ఎనీ ఫ్యూయల్ ఈస్ కన్సిడర్డ్ యాజ్ గుడ్ ఫ్యూయల్, ఇట్ మస్ట్ అవైలబుల్ వెరీ చీప్లీ, వెరీ మినిమల్లీ, ఇన్ఎక్స్పెన్సివ్ అనమాట. అది కొనాలి అంటే మనం వెరీ లెస్ అమౌంట్ పెట్టి కొనాలి, అలాంటి లో కాస్ట్ ఉన్నదాన్ని గుడ్ ఫ్యూయల్ అంటాం. If any fuel satisfy all these 6 important points, then that fuel is called as good fuel. So good fuel possesses all these kind of characters. So if a fuel contains these characteristics, without any doubt, damn sure that fuel is considered as good fuel. So these are the characteristics of good fuel. And next, I already said calorific value, and calorific value are of again 2 types. Calorific values are 2 types. Calorific values are again classified in 2 types. One is high calorific value HCV and LCV, low calorific value. High calorific value, low calorific value. High calorific value means simply high calorific value is also calorific value, but the products of combustion again bring back to room temperature. That means if a fuel contains high calorific value, that fuel at the end of the reaction or at the end of combustion, some kind of products will be formed. That product should be bring back to normal room temperature. Those kind of phenomenon is called as high calorific value. That means products of combustion again cooled down, again cooled to room temperature. So this is called a high calorific value. Low calorific value means this is a phenomenon in which the products of combustion tends to escape easily. Simply, products tends to escape easily. This is what low calorific value. This is all about calorific values. Now, one more important concept in your topic is calculation of O2 required. Calculation of O2 required for combustion of methane and ethane. So calculation of O2 required for combustion of methane. Ethane burn అవ్వాలంటే ఎంత అమౌంట్ ఆఫ్ ఆక్సిజన్ మనం అప్లై చేయాలి, అది క్యాలిక్యులేట్ చేయాలి. ఫర్ ఎగ్జాంపుల్, నౌ వీఆర్ మూవింగ్ ఆన్ టు methane. For combustion of 1 mole of methane, we need at least 1 mole of oxygen. For combustion of methane, we need at least for combustion of 1 methane, we need 2 moles of oxygen to form 1 mole of carbon dioxide plus 2 moles of H2O. See, for the combustion of 1 mole of CH4, that is methane, we need at least 2 moles of O2. As a reaction proceeds in this way, at the end the products formed is 1 mole of carbon dioxide and 2 moles of H2O will be formed. So this is how the methane will be undergoes combustion. Now coming to ethane. 2 moles of ethane C2H4 requires approximately 7 moles of O2. It gives rise to 4 moles of CO2 plus 6 moles of H2O. See, if 2 moles of ethane molecules require approximately 7 molecules of O2, leads to formation of 4 moles of CO2 and 6 moles of H2O. Generally, the calorific value of methane is approximately 55.6 kilocalorie per gram. It is of 47.486 kilocalorie per gram. So the calorific value of methane is approximately 55.6 kilocalorie per gram. The calorific value of ethane is 47.486 kilocalorie per gram. These are the experimental data. అంటే ఎక్స్పెరిమెంట్ సైంటిస్ట్ చేసి మనకి ఇచ్చిన డేటా ఇది. సో దిస్ ఈజ్ హౌ ద మీథేన్ రిక్వైర్డ్ 2 moles of oxygen and 2 molecules of ethane require 7 molecules of O2. Finally, byproducts are carbon dioxide and water. Calorific values are series. 55.56 for methane because the calorific value means 55.6 kilocalorie per gram amount of heat is liberating when the methane is undergoing combustion. That is the reason. That is a phenomenon. Here 47.486 kilocalorie per gram. This is all about calculation of O2 required for combustion, and that is about the calorific values of both those things. Now we are moving on to, these are examples for different fuels. Now in your syllabus we have different types of fuels. First one is CNG. What is CNG? Which is very, very important. CNG stands for, or abbreviated as, compressed natural gas. Compressed natural gas. So these are the gaseous fuels. Gaseous fuels. So in the gaseous fuels we must study different types of gaseous fuels. In that, first one is CNG. CNG stands for compressed natural gas. How it is formed? Compressed natural gas is generally formed by compression of natural gas, at high pressure, approximately 1000 atmospheric pressure. When the natural gas is compressed at high pressure, which is roughly about 1000 atmospheric pressure, when the natural gas is suppressed about 1000 atmospheric pressure, it will convert into compressed natural gas. For example 15 kg of cylinder, natural gas CNG cylinder, for example 15 kg of CNG cylinder contains approximately 20 meter cube of natural gas. See, natural gas is nothing but it is a naturally existing gas from which the compressed natural gas is formed due to the compression at high pressures. So for example, if we take 15 kg of CNG cylinder, it contains approximately how much? 20 meter cube of natural gas. And uses means CNG is generally used for various vehicles, used in vehicles as fuel, used for domestic purposes, used in fuels and domestic purposes. So this is what about CNG. Now we are moving on to LPG. What is meant by LPG? LPG abbreviated as liquefied petroleum gas. Liquefied petroleum gas. So liquefied petroleum gas. LPG stands for liquefied petroleum gas. Liquefied petroleum gas means it is generally formed by cracking of high molecular weight of hydrocarbons. So LPG is generally formed by cracking or breakdown of hydrocarbons. Cracking or breakdown of hydrocarbons. breakdown of hydrocarbons. Generally the calorific value of LPG is approximately 27,086 kilocalorie per meter cube. So LPG is the liquid petroleum gas which is generally formed by cracking or breakdown of hydrocarbons, whose calorific value is approximately 27,086 kilocalorie per meter cube. So generally it is used for various domestic purposes and also used for motor fuels. And compare the calorific value of LPG with that of natural gas, it is 3 times more. So LPG CV calorific value is 3 times greater than that of natural gas. So the calorific value of LPG is 3 times more than that of natural gas. So this is all about LPG. LPG stands for liquefied petroleum gas. It is generally formed by cracking or breakdown of hydrocarbons, and whose calorific value is 27,086 kilocalorie per meter cube, and the LPG calorific value is approximately 3 times greater than that of natural gas. This is all about LPG. Now we are moving on to water gas. What is meant by water gas? So water gas is generally called as blue gas. It is also called as blue gas. So generally the water gas is a combination of both CO plus H2 or CO carbon monoxide N2. So the combination of carbon monoxide plus hydrogen gas, or the combination of carbon monoxide with nitrogen gas, is considered as water gas, whose calorific value is approximately 2,800 kilocalorie per meter cube. This is the calorific value of water gas, generally used for, it is also used for various domestic purposes. So domestic water gas is also called as blue gas. It is a combination of carbon monoxide and H2. The calorific value is 2,800 kilocalorie per meter cube, and water gas is generally formed by passing steam, over red hot coke. So water gas is generally formed by passing steam, in the sense water vapor, by passing water vapor over the red hot coke. Then the fuel which is formed is called as water gas. This is all about water gas. Next we are moving on to coal gas. What is meant by coal gas? Coal gas is simple. It is also one of the fuel which is generally formed by the process called as carbonization. By the carbonization of coal, a specific type of fuel is formed. That fuel is called as coal gas. So it is generally formed by carbonization of coal, whose calorific value is approximately 4,900 kilocalorie per meter cube. So the calorific value is 4,900. Generally the coal gas is generally used or uses, especially it is used in metallurgical applications. It is used in metallurgical applications. So metallurgical application, coal gas is nothing but it is formed by the carbonization of coal. Coal ni carbonization ane technique ద్వారా చేస్తే అప్పుడు వచ్చేదే coal gas. ఇది మెటలర్జీలో ఎక్కువగా వాడతారు. మెటలర్జీ అంటే మైనింగ్ ఆఫ్ మెటల్స్ ఫ్రమ్ ఓర్స్. సో whose calorific value is approximately 4,900. Now we are moving on to biogas. It is also very important concept. Nowadays we are most interesting and paying attention towards biogas. Biogas is nothing but, in the name itself there is bio. That means the gas, the fuel which is formed due to the degradation of biological material or biological matter. So biogas is formed due to degradation of biological matter by bacterial action, by bacteria or bacterial action. See, biogas is generally formed due to the degradation of biological matter by bacteria. ఒక బాడీ అనేది హ్యూమన్ బాడీ కావచ్చు, ప్లాంటే కావచ్చు, ఏదైనా ఒక బయాలజికల్ థింగ్ ఉందనుకోండి, అది బ్యాక్టీరియాతో రియాక్ట్ అయినప్పుడు అక్కడ ఫామ్ అయ్యే గ్యాస్ ఏదైతే ఉంటుందో దాన్ని బయోగ్యాస్ అంటారు. ద బెస్ట్ ఎగ్జాంపుల్ ఫర్ ద బయోగ్యాస్ మెనీ గోబర్ గ్యాస్ ఇవన్నీ బయోగ్యాస్. సో యాజ్ అ రిజల్ట్ ఆఫ్ బయోగ్యాస్ ఆల్సో హ్యావ్ అప్రాక్సిమేట్లీ 5600 kilocalorie per meter cube is the calorific value. The biogas is mainly useful in the case of domestic purposes such as cooking can be used this biogas, and also for motor fuels. So this also biogas is repeatedly used. Now this is all about biogas. Now the last and least one is producer gas. Producer gas is not that much important. It is produced from the combination of CO2, N2 plus H2. Producer gas is nothing but it's a combination of carbon monoxide, carbon dioxide and N2 and H2. Among these four things, the CO2 and N2 are the impurities. They are not in the combustible nature. But CO and H2 are combustible, which is also part of water gas lo kuda manaku CO H2 చూసాం. In addition to that, ఇక్కడ CO2 N2 కూడా ఉంటాయి. So example, this producer gas is mainly useful for as reducing agent in metallurgy. So the producer gas is generally used as reducing agent in metallurgy లో reducing agent గా వాడతారు. సో producer gas అంటే ఏంటి? CO ఇది కూడా ఎలా ఫామ్ అవుతుంది? The producer gas is also formed by passing steam over hot coke at approximately 1300 degrees centigrade temperature. సో స్టీమ్ని మనం హాట్ కోక్ మీద పంపించినప్పుడు ఇక్కడ 1300 డిగ్రీ సెంటిగ్రేడ్ దగ్గర పంపించినప్పుడు అది ప్రొడ్యూసర్ గ్యాస్ని ఫామ్ చేసింది. సో దిస్ ఈజ్ ఆల్ అబౌట్ డిఫరెంట్ కైండ్స్ ఆఫ్ ఫ్యూయల్స్. సో నౌ ఇన్ దిస్ టాపిక్ వీ హ్యావ్ స్టడీడ్ fuels, what are the contents in the fuels. Second one, what is the definition of fuels and what is the combustion. In the third step, we are studied about what are the classifications of fuels, and in this source, depending upon source, how the fuels are classified and their examples. And in this, based on the state of aggregation, the fuels, how the fuels are classified and their examples. And in this, what is the concept of calorific value, what are the units of calorific value, how the calorific value is associated with efficiency of the fuel. And now these are the characteristics of good fuel, and two types of calorific values. Calculation of O2 required for combustion. This is all about gaseous fuel, CNG, LPG, water gas, coal gas, biogas, producer gas. So this is all about fuels. Now we are moving on to next topic, that is lubricants. Now we are important topic, that is lubricants. The topic lubricants is very minute topic. You can definitely very easily understandable topic. Lubricants are nothing but the lubricants, for example, whenever if you see any heavy machinery, our parents and our cousins or our neighbors will use it to apply some kind of grease, oils onto the machinery parts. So అంటే ఏంటంటే ఒక మెషిన్ని చూసినప్పుడు మనం ఏమవుతుంది, the machine is made up of metals. So when the machine is working, one metal can able to colloid or roll over other metal. అంటే ఒక మెటల్ అనేది ఇంకో మెటల్ యొక్క సర్ఫేస్ మీద రోల్ అవుతూ ఉంటుంది. Due to the rolling or due to the sliding of one metallic surface over the other metallic surface, some amount of friction is developed. Friction is nothing but heat energy అనేది ప్రొడ్యూస్ అవుతుంది. ఆ హీట్ ఎనర్జీ వల్ల ఎఫిషియన్సీ ఆఫ్ మెషిన్ అనేది తగ్గిపోతుంది, మెషిన్ వర్కింగ్ కండిషన్ తగ్గిపోతుంది. సో ఇన్ ఆర్డర్ టు ప్రివెంట్ దట్, In order to prevent the formation of friction, some kind of substances or some kind of agents are generally used. So those agents are called as lubricants. The lubricants are defined as substances that is applied in between the machinery parts to reduce friction. So that is called as lubricant. These are defined as, these are generally defined as substances used to prevent formation of friction, to prevent formation of friction. These are called as lubricants. These are about, this is a basic and important definition of lubricants. And now we are going to discuss about classification of lubricants. There are especially 3 types of lubricants are there. Classification, one is liquid lubricants, second one is semi-solid lubricants, third one is solid lubricants. Solid lubricants, liquid lubricants, solid lubricants, and this is solid lubricants. See, liquid lubricants. Liquid lubricants are the lubricant that exists in the state of liquid, especially generally oils, vegetable oil, palm oil, animal oils. These are the liquid in state, those can use to reduce friction. So the best examples for the liquid lubricants is vegetable oils, animal oils, and synthetic lubricants. So these are the examples for the liquid lubricants. Semi-solid in the sense, semi-solid lubricants are the lubricants that exist in both the phases, such as liquid and solid properties. అంటే ఏ lubricant లో అయితే solid మరియు liquid properties ఉంటాయో దాన్ని semi-solid lubricants అంటాం. These semi-solid lubricants are generally formed by the process of emulsification of oils. Oils ni emulsification అనే process ద్వారా ఇది form. The best example is greases. By process called as emulsification of oils. Emulsification of oils, these are generally formed. Now solid lubricants, the best and most important solid lubricants are graphite, and one more important is a molybdenum disulfide, and one more is boron nitride. So these are the 3 important solid lubricants. How the graphite and molybdenum is to use? In the graphite, generally graphite exists as layers, one carbon layer, carbon layer. So in between those carbon layers there is weak van der Waals forces of attraction. Weak forces ఉంటాయి ఆ layers మధ్యలో. అది అలా ఉండడం వల్లనే graphite can be easily used in between the machinery parts in terms of lubrication. ఆ lubrication ని ఈజీగా చేయగలుగుతుంది graphite and molybdenum. So these are the different types of lubricants. And now applications of lubricants are very important. Applications involve why the lubricants are more important to us. First application is, if there is no lubricant, if there is no lubrication, what will happen? If there is lubricant, if there is no lubricant, there is a chance of increasing of friction. As the friction develops more rapidly, there is a chance of rusting and corrosion. So the lubricants are generally added to the machinery to reduce friction such that the process of rusting and corrosion will be eliminated. So these are used to prevent rust and corrosion. And these lubricants are also used in the medicines. And these are also used in soap and soap industry simply. It also uses soap. And fourth, so lubricants are generally used to prevent rust and corrosion, and in the medical applications it is also used in soap and soap industries, and it is used also antioxidants also. Lubricants are also acts as antioxidants. So these are the 4 important applications of lubricants. First, definition in the sense, these are the substances generally used to reduce the friction developed between the metallic or heavy machinery parts. So the classification is based on the state, based on their state of appearance. Based on the state, liquid, semi-solid, solid lubricants. Under liquid, we generally use oils, vegetable oil, animal oils and synthetic lubricants. Under semi-solid, these are the produced as a result of emulsification of oils. So example, greases. Solid lubricants, example, graphite, molybdenum disulfide and boron nitrate. Applications involved to prevent rust, medicines, soap, antioxidants. These are the applications of lubrication. This is all about lubricants and the types and their applications. So completed. Now we are moving on to explosives. It is also very important. Explosives. What are explosives? Explosives means what? We have studied what are fuels, we have studied what are lubricants. Now the topic is explosives. Explosives in the sense, explosives are the substances that can rapidly expand into gases. That can rapidly, it is explosion means substances that can rapidly expand into gases, followed by generation of heat. This is called as explosive. Explosives are the nothing but explosives are the substances that can rapidly expand into gases. అంటే అవి ర్యాపిడ్గా గ్యాషియస్ స్టేట్కి ఎక్స్పాండ్ అయిపోయి మోర్ అమౌంట్ ఆఫ్ ఆర్ మ్యాసివ్ అమౌంట్ ఆఫ్ హీట్ విల్ బి జనరేటెడ్. అండ్ ఎక్స్ప్లోజివ్స్ ఆర్ జనరల్లీ classified into 3 different types based on the source from there which they prepared. So based on the source, these are classified into 3 types. One is chemical explosives, mechanical explosives and nuclear explosives. So one is chemical explosives. Chemical explosives in the sense, chemical explosives. Explosives are generally classified in 3 types: chemical, mechanical and nuclear. Chemical explosives are the explosives that can decompose rapidly at high temperatures and high pressures and generate high amount of pressure. Example, TNT is the best example, Trinitrotoluene. It is also dynamite. So chemical means it is characterized by decomposition rapidly and generation of more amount of pressure. So rapidly decomposed. These are the chemicals. Mechanical in the sense, these are the explosives which are decomposed due to mechanical stress. దాని మీద ఏదైనా మనం లోడ్ కానీ స్ట్రెస్ కానీ అప్లై చేసినప్పుడు అది ఎక్స్ప్లోడ్ అవుతుంది. So that is called as mechanical, due to mechanical stress or mechanical load. Stress or load. So this is all about mechanical explosives. Next, nuclear explosives. The nuclear explosives is very important thing. These nuclear explosives are nothing but their radioactive isotopes will be utilized. So radioactive as uranium, polonium, these kind of things are there. These kind of isotopes are generally used for the process of explosion. It produces large amount of heat when compared to both chemical and mechanical. Especially these nuclear explosives are generally used for extraction of petrol, for petroleum exploration or for petroleum extraction. So nuclear explosions produce more amount of energy, especially used for petroleum extraction from the earth crust. Now applications of explosives are very important. Applications of explosives. First application is, it is mainly used mining and quarrying. Mining and quarrying. Second, it is used for construction. It is mainly used for military applications, military. And it is used in metallurgy. And it is used for various excavations. Simply archaeology. Explosives have wide range of applications. Some of the applications are used as mining and quarrying. Mining and quarrying. Mining, quarrying in the sense, explosives are generally used to fragment the rocks. The rocks are very dense. So in order to break down that rocks, the engineers will adjust or apply certain kind of explosives there. By placing those explosives, the rocky substances undergoes fragmentation such that they can extract valuable minerals from rocks. So generally in the mining, especially used to fragment rocks, to fragment mukkal cheyadaniki vaadtaru idi. I think you are familiar with this. Construction. In the construction, generally the explosives are used to demolition of buildings. పెద్దగా అన్ని అంటే అవసరం లేకుండా ఉన్నటువంటి బిల్డింగ్స్ ఏవైతే ఉంటుందో వాటిని మనం కూలగొడుతూ ఉంటాం, డిమోలిషన్ అంటాం. ఫర్ ద పర్పస్ ఆఫ్ డిమోలిషన్ వి జనరల్ యూజ్ కన్స్ట్రక్షన్. Explosives are used for demolition of buildings. Military, we know that why the explosives are military. In order to destruct the enemy territories, we generally used military for destruction of enemy bunkers. Destruction of enemy bunkers, military applications. Metallurgy means for process of ore extraction. For ore extraction also it is also used. For ore extraction. And finally, excavation archaeology. Archaeology means the main purpose of archaeological department is to extract ancient antiques present in the soil. So when soil is very hard, so sometimes they have to place some explosives to make sure that soil into the fine particles. So at the times of excavation of archaeological sites also explosives are used, especially for identification of antiques. So these are all about applications of explosive. First one is mining and quarrying. Generally explosives are used in mining and quarrying for fragmentation of rocks. Second one is construction, for demolition of old buildings. Third one is military, especially destruction of enemy bunkers. And metallurgy means generally to extract ores from earth crust. In the archaeology, generally identification of antiques, where the ancient valuable things are located, we can, with the help of explosives, they can find out. So this is all about, this is our fuel, lubricants and lubricants. So this is all about that. Now, and finally, and myself Chandra Prakash and faculty of chemistry Ecet. This is Ask Engineering Academy located at Dilsukhnagar. So anybody student interested to join this institution for various coachings such as NEET, IIT, Ecet and JEE mains and especially Ecet and BTech backlogs and any tuitions. So you can directly contact the details which are produced in the description box. So thank you so much for listening my class and thank you for this opportunity. I am very happy to be part of these institutions from the past many days and I think you are very happy with my class and